Right, so we started 6.4 the other day, and we talked about factoring, and we showed sum and difference of cubes, grouping, and all the different factoring methods. Today, we're going to talk about why do we have to know how to factor? What is the point? What does it do for us? And we can use that to solve equations, solve polynomials that have bigger exponents. So if we look at number 1, we have 2x to the fifth plus 24x equals 14x to the third. So what we want to do when we're solving is we want to make it equal 0. So we'll make a little note here. Make equal to 0. So we're going to minus 14x to the third. And we get 2x to the fifth minus 14x to the third plus 24x equals 0. So we set equal to 0 by subtracting 14x to the third. And then now we got to try to factor this. Because there's no way, there's nothing that combines. We can't like put the x to the third with the 2x to the fifth. So we have to factor. That's the only way to solve this. So what is the GCF? That'd be the first thing we start with. And the GCF, we can divide everything by 2, and everything has at least 1x. So we're going to divide everything by 2x. And we are going to put 2x in the front, and the leftovers will come after. So x to the fourth minus 7x squared plus 12. So we took out a GCF. Now we got to see, can we factor some more? Can we factor what's in parentheses a little more? And we can, because we have x to the fourth minus 7x squared plus 12. We can try to factor this by doing what we call a smiley face method. What multiplies to x to the fourth? X squared times x squared. And now we want to pick numbers that multiply to 12, but will give us negative 7x squared. So numbers that multiply to 12 are 6 and 2, 3 and 4, 12 and 1. Well, let's try 3 and 4. Is there a way that we can do this so that the inside can give us, the inside and the outside, when you add them up, give us negative 7? So we need it to be a negative 3 and a negative 4. So it's minus, because now we have negative 7x squared. That's what we wanted. And negative 3 times negative 4 is 12. So we were able to factor that out to x squared minus 3 times x squared minus 4. Okay, now we have to check, can we factor anything else again? So we have 2x, which can't be factored. We have x squared minus 3, which can't be factored, but x squared minus 4 can be factored. You'll notice that x squared and 4 are both perfect squares. X times x is x squared. 2 times 2 is 4. 1 plus sign, 1 minus sign. And everything else will stay the same. So we have 2x, x squared minus 3, x plus 2, x minus 2. So a lot of factoring. It was the GCF, it was smiley face, and then we did difference of squares. So now we're going to come over here. I'm going to rewrite this. 2x, x squared minus 3, x plus 2x minus 2. So we factored, made it equal to 0. Now all we have to do is solve this. So we have 3 things that we factored out, and we have to set those all equal to 0. So 2x equals 0. X squared minus 3 equals 0. X plus 2 equals 0. And x minus 2 equals 0. and we're trying to find all of the real number solutions. So see which ones actually come out to nice real numbers. So the first one, 2x equals 0. If we divide by 2, x equals 0 divided by 2. 0 divided by 2 is 0. The second one, we would add 3. X squared equals positive 3. Take the square root, because we're solving for x now, we take the square root, x equals plus or minus square root of 3. That's a real number, or real numbers, because there's no I, there's no imaginary. The next one, you'll subtract 2 to get x alone, so x equals negative 2. And the last one, we add 2, and we get x equals positive 2. So these are our real solutions. And again, real means there's not imaginary or there's no I. So here there's no I's, so they're all real solutions. Okay, and then just a little hint, which is pretty new to us. If the biggest exponent is 5, there could be anywhere up to 5 real solutions. Number 2. Yeah, there's a couple ways we could solve this. Let's solve it by factoring. So we have 2 perfect cubes. So we're going to do the cube root of each. Cube root of x to the third is x. And the cube root of 27 is 3. Actually, I'm going to show you a faster way. So we'll factor this and I'll show you a faster way. So difference of cubes, we have 2 sets of parentheses. Okay. X and 3 go in the first parenthesis. In the second parenthesis, you take x and you square it. The middle part is 3 times x, and the last part is 3 squared, which is 9. And the symbols are going to be the same, so a minus sign, the opposite, and a plus. Okay, and these are equal to 0. Okay, so now you would set the first parenthesis equal to 0, x plus 3 equals 0, and you would solve. Subtract 3 to get x equals negative 3. So that's one real solution. The second part, we set this equal to 0, x squared plus 3x plus 9 equals 0. And we can't factor that anymore, and we can't really just solve that. So what we end up doing, actually I just realized something. I messed up a symbol. Go back and change this. This should be over here, should be a minus sign. Let me fix that for you. It should be x minus 3, and then the answer is actually x equals positive 3 because I messed that up. So sorry, fix that. We'll go on to the next part of this. My mistake. Should be a plus 3, not a minus 3 as our answer. So the second part in blue. Since we can't factor it, we can try doing a quadratic formula where a equals 1, b equals 3, c equals 9. So we do quadratic formula. Remember the formula is negative b plus or minus square root of b squared minus 4ac all over 2a. That's the formula we use. So the opposite of b is negative 3. And then we have 3 squared minus 4 times a times c, all divided by 2 times a. So we substitute in a, b, and c. And now you can take a calculator out, and you can find out what is 3 squared minus 4 times 1 times 9. And we end up with negative 27. So negative 3 plus or minus negative 27. So what we have a square root of a negative number. The square root of a negative number is going to have an imaginary solution. So these are imaginary. So they're imaginary solutions, which means they're not the real solutions we're looking for. So the only real solution we have is x equals positive 3. So whenever we solve these and we get a square root of a negative, it's imaginary. So there's 2 imaginary solutions. And the last one, make it equal 0. So we're going to subtract 2 from both sides. X to the third plus 2x squared minus x minus 2 equals 0. That's step 1. We have 4 terms. 4 terms means we must do grouping. So group the first 2 and take out a GCF. The GCF is x squared. So we end up with x squared and then x plus 2 in the parentheses. When you group the second 2, the only GCF we have is a negative 1. And again, make sure you do a negative 1 because the negative sign is in front of this group. So it's negative 1 and then positive x and a positive 2 because negative 2 divided by negative 1 is positive 2. So what we have now is the same thing in parentheses, which is good. That's what we wanted. Take out what's in common in the parentheses that goes in front, and the leftovers come after. So x plus 2, x squared minus 1. All right. Now what we do is we take the 2 parentheses and set them equal to 0. So we have x plus 2 equals 0. If we solve this, x equals negative 2. Then take your second parenthesis, x squared minus 1 equals 0. Okay, and we can solve this a couple ways. We could factor it, or we could just try to get x alone. So we could factor it, and it'd be a difference of squares. It'd be x plus 1, x minus 1 equals 0. So factoring it will get you to the answer because now we just set them equal to 0. X plus 1 equals 0. X minus 1 equals 0. And you solve this. X equals negative 1. X equals positive 1. So those would be our 3 answers. Negative 2, negative 1, and positive 1. I just want to show the other way you could have solved this, which is totally fine. You could have added 1 to get x squared equals 1, and then taken the square root to get x equals plus or minus 1. So that way would get you the same thing, a positive 1 and a negative 1. Gets the same answer. I just want to show there's more than one way to do it. All right, so we're still factoring. We just set them equal to 0 and we solve it.